Imagine a world where your house runs on a device the size of a toaster, fueled by something as ordinary as table salt. Sounds like science fiction, right? Well, that's the promise of cold fusion, a technology that has the potential to revolutionize the way we generate energy. But what exactly is cold fusion, and is it too good to be true? Buckle up, because we're about to dive into the fascinating and complex world of cold fusion, separating fact from fiction and exploring its potential to create a cleaner, brighter future. First, let's talk about traditional nuclear power. It works by splitting heavy atoms apart in a process called fission, releasing a huge amount of energy. However, fission comes with baggage, radioactive waste, and the risk of accidents. Enter cold fusion. This theory proposes a different approach, fusing lighter atoms together at room temperature and pressure, mimicking the process that powers the sun. Think of it like creating tiny stars on Earth, harnessing the same energy source that fuels our solar system. Sounds amazing, right? Well, the story of cold fusion is a wild ride. The idea emerged in the late 1980s, sparking a frenzy of excitement. Initial claims of success were met with cheers, but attempts to repeat the results often failed. This discrepancy led many scientists to dismiss cold fusion as a cold fusion fiasco. However, the story doesn't end there. While the initial claims may have been overblown, the idea of cold fusion hasn't completely disappeared. Research continues in labs around the world, exploring new theories and techniques to unlock its potential. So how exactly is this supposed to work? The specifics are still being debated, but the basic idea involves manipulating certain materials, like palladium and deuterium, a form of hydrogen, to create conditions where atomic nuclei can fuse together, releasing energy in the process. It's important to remember that there are significant challenges. Replicating the experiment consistently is one hurdle, and even if successful, scaling it up for large-scale energy production presents another set of complexities. Engineering challenges, energy efficiency, and potential safety concerns need to be addressed before cold fusion can become a reality. Scientists in California have taken a significant step towards clean energy with the successful replication of a breakthrough fusion reaction. His process involves fusing atoms like those in the sun to release vast amounts of energy without producing harmful radioactive waste. In December 2022, researchers at the National Ignition Facility, NIF, at Lawrence Livermore National Laboratory achieved a world first, a fusion reaction that generated more energy than it used. This process, called ignition, has now been successfully repeated 3 times in 2023, marking a major milestone in the fight against climate change. For decades, scientists have been striving to harness fusion energy, aiming to recreate the sun's power on Earth. The recent replications demonstrate the stability and control of the process. Even with variations in the lasers or fuel, each experiment provides valuable data to refine the technology and maximize energy output. Unlike traditional nuclear fission, which releases energy by splitting atoms, fusion is cleaner and safer. It doesn't leave behind long-lived radioactive waste, making it an attractive solution for a sustainable future. How it works. At NIF, scientists fire nearly 200 high-powered lasers at a tiny pellet of hydrogen fuel contained within a diamond capsule and a gold cylinder. The lasers create intense heat, triggering compressed explosions that release significant energy captured as heat. While the initial energy output in December 2022 was small, enough to boil a few kettles, it was sufficient to prove the concept. Since then, scientists have achieved even higher energy yields. However, scaling this technology for commercial use remains a challenge. Researchers are now focusing on increasing energy output and reducing costs to bring fusion energy closer to reality. This progress has garnered international attention. At the COP28 Climate Summit, the US launched an initiative involving over 30 countries to accelerate fusion research. Additionally, the US Department of Energy is investing in programs to advance fusion technology. Secretary of Energy Jennifer Granholm stated, "Harnessing fusion energy is one of the greatest scientific challenges of our time. Now, we have the confidence that it can become a reality. While challenges remain, the recent advancements in California are a promising step towards a clean and sustainable energy future powered by fusion energy. While the path to large-scale fusion energy remains long, The recent advancements in California offer a glimmer of hope for a cleaner future. This milestone demonstrates the dedication and progress of scientists worldwide in tackling the climate crisis through innovative approaches like fusion energy. Continued international collaboration and investment can pave the way for a future where clean and sustainable energy powers our homes and reduces reliance on fossil fuels. The journey to harnessing the sun's power on Earth may be long, but the potential rewards are worth the pursuit. Thank you for watching. If you found this exploration into the revolutionary world of cold fusion as exciting as we do, don't forget to hit that like button and subscribe to our channel for more groundbreaking science content. Your support helps us dive deeper into the mysteries of the universe and bring you the latest discoveries and innovations. Got any thoughts or questions? Drop them in the comments below. We love hearing from you. Until next time, stay curious and keep exploring with us. See you in the next video.